Chapter 2, Section 2. The slope of a line on the coordinate plane is the measure of its slant. So let's take a look at a line on the coordinate plane, a line in general. And let's label 2 points on that line, x sub 1, y sub 1. And x sub 2, y sub 2. Now let's draw a vertical line through one of the points and a horizontal line through the other point, creating this right triangle. And find the coordinates of the point at the right angle. We'd have to go over x sub 2 units from the origin and down y sub 1 units. So the coordinates of the point at the right angle would be x sub 2, y sub 1. And now find the distance parallel to the y-axis along this leg from this point to the right angle. That distance is called the rise. And it would be difference in y coordinates. Y sub 2 take away y sub 1. The distance along this leg of the right triangle from this point to the right angle is called the run. And we can find that by taking difference in x coordinates. X sub 2 take away x sub 1 would give us that length. So the slope of any slanted line on the coordinate plane is rise divided by run. It's defined to be the difference in y coordinates divided by the difference in x coordinates. So using that slope formula, let's find the slope of the line that passes through negative 2, 3 and 1, negative 5. First we'd have to subtract the y coordinates in the top. So negative 5 take away 3. And subtract x coordinates in the bottom, 1 take away negative 2. So simplifying, we're going to have a total of negatives in the top, negative 8, and we have double negatives in the bottom, so it's going to be 1 plus 2 or 3. So we get a negative slope, negative 8/3. Now if we look at this line on the coordinate plane, graph negative 2, 3, and 1, negative 5, and draw the line through those 2 points, we see that this line falls from left to right on the coordinate plane, and it has a negative slope. Okay, looking at the slope of these 3 lines quickly, and using our formula for slope, we're going to take a difference in y coordinates on the top, negative 1 take away negative 4, and difference in x coordinates on the bottom, 3 take away a negative 2, so on the top, double negatives again, it's going to be negative 1 plus 4, that's 3, and 3 plus 2 on the bottom is 5. So here we have a positive slope, 3/5. And if we look at that line on the coordinate plane, negative 2, negative 4 in the 3rd quadrant, 3, negative 1 in the 4th quadrant, and draw the line through those 2 points, we find that it rises from left to right and has a positive slope. Okay, in example 2 here, or problem 2, difference in y coordinates, negative 2 minus 2. Notice that our y coordinates are the same. And difference in x coordinates on the top, 3 take away 1. Simplifying, we have negative 2 plus 2, that's 0 on the top. 3 take away 1 is 2. But we know 0 divided by anything is 0. And if we graph this line, graphing 1, negative 2, and 3, negative 2, we see that we have a horizontal line. The slope of a horizontal line is going to be 0. And the slope of this third line, difference in y coordinates, negative 5, take away 4 on the top. And difference in x coordinates on the bottom, 2 take away 2. Notice in this problem the x coordinates are the same. So we're getting a total of negatives on the top, negative 9, and on the bottom 2 take away 2 is going to give us 0. Now we know in our real number system dividing by 0 is undefined. So this line has a slope that's undefined. And if we look at it on the coordinate plane, we're graphing 2, 4 in the first quadrant and 2, negative 5 in the fourth quadrant. And connecting those points, we see that our line is vertical. A vertical line is going to have a slope that's undefined. So just summarizing what we've looked at, if a line has a negative slope, the line falls from left to right on the coordinate plane. If a line has a positive slope, the line rises from left to right on the coordinate plane. If a line has a slope of 0, we know that the line is horizontal on the coordinate plane. And if a line has a slope that is undefined, the line is vertical on the coordinate plane. Here's another point that we need to make. The line with a slope larger in absolute value is steeper on the coordinate plane. Now we're going to compare parallel lines and perpendicular lines. Parallel lines are two lines that don't intersect, and we can indicate parallel lines using little arrows. Parallel lines have equal slopes. Since the slope of a line is its measure of its slant, if two lines never intersect, they're going to have the same slant, which means their slopes have to be the same or equal. Perpendicular lines intersect at right angles, and to indicate that two lines are perpendicular, we use a little box to indicate that they intersect at right angles. Perpendicular lines have slopes that are opposite reciprocals. So let's take a look at this example. We want to answer the question, are lines 1 and 2 parallel, perpendicular, or neither? So to decide, we want to compare the slopes of those two lines. So let's find the slope of line 1. I'll call it m sub 1. And I'll take a difference in y coordinates, negative 2, take away 1 on the top, difference in x coordinates on the bottom, 4 take away a negative 3. So I get a total of negatives, negative 3 on the top, and 4 plus 3, or 7 on the bottom. So this slope is negative 3/7. Now the slope of line 2, which I'll call m sub 2, is equal to difference in y coordinates on top, 4 take away a negative 3, and difference in x coordinates on the bottom, 0 take away a negative 3. So on the top we have 4 plus 3, which is 7, and on the bottom we have 0 plus 3, which is 3. So we get a slope of 7/3. Now those slopes are opposite reciprocals of one another. The reason I know that is because if I multiply negative 3/7 and positive 7/3 together, I get negative 1. A product of negative 1 indicates that we're multiplying reciprocals. Opposite reciprocals. So that tells me that line 1 is perpendicular to line 2. This is the notation that we use to indicate perpendicular lines. If the lines had been parallel, we could use this symbol line 1 is parallel to line 2. But in this example, that's not the case. Those lines are perpendicular. In application problems, slope is referred to as average rate of change, like miles per hour, dollars per year, or cost per pound. In this example, we want to find the average rate of change in y relative to x for the ordered pairs 0, 11 and 3, 50. X is measured in gallons and y is measured in miles. So since we're finding an average rate of change, and that's just slope, we'll use our slope formula. We'll take a difference in y coordinates, 50 take away 11 in the top, and a difference in x coordinates in the bottom, 3 take away 0. So simplifying, we're going to get 39 in the top and 3 in the bottom. 39 divided by 3 is 13. Now this is an average rate of change, so it deserves a label. Since y is in the top and it's measured in miles, and x is in the bottom and it's measured in gallons, we just found that our average rate of change is 13 miles per gallon. Include in your notes of this video guided practice problems 6 through 12 found on pages 83 and 85 of your textbook.